In this video, we'll go over event-driven programming. We'll specifically look at anonymous classes and observable objects. So in the previous video, we looked at how you can use inner classes to create our listener objects. Sometimes it's also useful to, in addition to creating them as inner classes, they can also be created as anonymous inner classes, as in there's no need to provide a name to the class. We basically just directly create it in line wherever the object is needed. So basically the way it works is that you don't have to explicitly specify the keyword class or extends and implements. We assume that it's always going to extend a superclass or implement an interface. So you basically directly provide the name of that superclass or the interface. So you don't have extends, implements clauses specified. I'll show you an example of this, and then when the class is compiled, the anonymous inner class also gets compiled into a separate class, and because there is no name, it's basically going to use the outer class's name as a prefix, followed by a dollar symbol, followed by a number, the number being the first anonymous inner class gets 1, the second one gets 2, and the third one gets 3, and so on. So that's how the class files are generated. So here's how the syntax looks. So it basically inline just directly wherever the object is needed, you're going to create the object by saying new and provide either the superclass name or the interface name, and inside of it implement the methods, the abstract methods that are necessary. So that's how it works. So here's an example. So in this case, there's the button enlarge, and instead of having a separate enlarge handler class and then creating an instance of the enlarge handler, what we can do is, and this is the registration step where we're registering the handler object. So what we basically do is, inside that registration method where we have to pass the object, now we're going to write the entire class over there inline. So we're going to say new. We don't have to provide the keyword class. The class name is not needed. We don't need implements. Just specify the interface and then the method that we're going to implement, and then close the registration method. So basically inside this we have this entire class definition going in, and that takes care of the handler class. So let's look at an example. We have there's an example called anonymous handler demo. So let's quickly take a look at the code. Okay, here's the anonymous handler demo program. Basically, again, it's a Java FX code. So there is a stage that is set up, and all it has is the text programming is fun, and then there's a pane at the bottom with multiple buttons. There's a up, down, left, and right buttons. So there's 4 buttons, and the idea is when clicking on each of these buttons will basically move the entire text either up, down, left, or right. So we'll look at how anonymous classes are used here. So we're going to basically create and register a handler. So for button up, we want to set we want to register the handler. So set on action method. So this is where we need to pass the object. So we're creating a new object, and then we're creating it. We're using an anonymous class here. So here's the interface name, event handler, and then we need to provide the handle method implementation. So the handle method is basically taking care of moving the text up by a little bit. So in similar manner, inside button down, we are creating another handler class, which is also an anonymous class to move the text down, and then similarly for the left and right. So you see that the amount of code that needs to be written is shortened, and it's much easier to read. Instead of having separate inner classes, now we have everything in line wherever the registration is happening. So let's execute this program. So So here's the program that shows the text, and then it has the buttons. Clicking up is moving it up, clicking it down is moving it down, and so on. So next we'll look at how event handling can be done using lambda expressions. Lambda expressions is a new feature that was introduced in Java 8 to provide concise syntax, and it's heavily used with event-driven programming. So basically the idea is to further shorten the expression and allow the compiler to figure out some of the things. So earlier we saw how you can create an anonymous inner class to do the registration of a listener. So what with the corresponding lambda expression for it would be, so to the handle method, we are basically passing the event object that got generated when the event occurred. So all we need to specify is that event object. So the way lambda expressions work is given a certain input, so you specify the inputs followed by an arrow. So given these inputs, what are the statements that need to be executed? And you can specify multiple statements, or you can specify a single statement. So over here you see, given the event object, we want these statements executed. So the code that needs to be processed can be listed out. So that's how events can be handled. So here's the basic syntax, and then the inputs that are passed to it, there could be multiple inputs, in which case just comma separate them. You can specify the type, or you can skip the type and allow the compiler to infer that type. So here's the basic syntax, where we have the first parameter of type 1, second parameter of type 2, and so on. Comma separated list within parentheses, and if when those are provided, we want this expression executed. Or you can have a set of statements executed, in which case you specify the statements within curly braces. So that's the basic syntax. Now this works only for interfaces that are single abstract method interfaces, also known as functional interfaces, because if there are multiple abstract methods, then the compiler doesn't know which one to use. So lambda expressions can be used only for those interfaces where there's a single abstract method, and that's the only one that needs to be executed when the event occurs. So I'll show you an example of these lambda expressions being used in the loan calculator example that's available in the samples folder. So let me open up the Java file first. So here's the interface again with JavaFX. All of the text fields and the grid is set up to basically get input from the user. The purpose of this program is to allow the user to enter the annual interest rate, the number of years, and the loan amount, and then the program calculates what the monthly payment and the total payment would be. So you'll see that in the program there's labels and text fields where the user can enter these different fields, and then there's a total payment and monthly payment fields where the result will get printed. So we have those, and then there's a calculate button at the bottom, and clicking on the calculate button should trigger the event to basically perform the calculation. So we need to now register a handler for the button click, for the calculate button click. So here's our calculate button click, and we want to register. So set on action is the registration method, and you see how concise the syntax is over here. Instead of an entire having a separate inner class and then creating an object of that inner class, we have just this single statement now. So E is our event object that got generated when the button click happened with all of the event related information. And when this event given this E as the input, we want to basically invoke the calculate loan payment method. And then calculate loan payment method is provided over here. So here it's automatically figuring out the type of event that occurred, and the compiler is inferring that, because we are not specifying the type over here. You can if you want to, there's no problem with that, but then the compiler is able to infer that. And then so again the assumption is that the interface of that event type is a single abstract method. So there's a single abstract method called handle. So this calculate loan payment is basically corresponds to the instructions of that handle method. and then it does the calculation and prints it out. So let me quickly run the method, run the class to show you how it works. So here's the program. I'm going to enter an interest rate, say 5, number of years is 10, my loan amount is say 100,000, and then I'm going to hit calculate, and it does the monthly and total payment calculation for me. So that's how Lambda Express. So basically, they are really helping provide a concise syntax and an easy to read program. But again, can be used only where there are interfaces with single abstract methods. So next we'll look at some other kinds of event classes that are available in the Java API. Mouse event class is one very useful class. It has a number of properties that are useful, and these, so when a mouse event occurs, the event object that gets generated will basically hold all of this information. It has the XY coordinate of where the mouse is pointing on the source object. Then it also has the XY coordinates of the of where the mouse is pointing on the scene. So basically, the way JavaFX works is that there's multiple layers and there's container components. So the assumption is that the source object is at on the topmost layer, and then that is on a scene, and the scene is on a screen. So it provides the XY coordinates of all of those different layers. Along with that, it also provides some properties, so we can check if the Alt key was down when the mouse event occurred, if the Control key was down or not. So these are true, they return true or false based on whether those keys were pressed or not. So that's the mouse event class. There is a mouse event demo sample that can be that we can look at. So basically, again, over here there is the text programming is fun, and our idea is to use the mouse and drag it. So basically, on mouse dragged is the event that's getting tracked, and when that event occurs, it's basically setting the based on the x and y coordinates of where the event occurred, we are now setting the text's x and y coordinates. So that's how the mouse event demo works. Let's quickly take a look at it in action. So here's our demo, here's the text, and then if you see, as I'm moving it with my mouse, the text is also moving, and it was based on that lambda expression, which is the handling code to handle this. Now in a similar manner, there's a key event class to handle keyboard events. So when anything related to the keyboard happens, that's when this event is triggered. It basically provides information about which character was associated with the event code. Every key on the keyboard has a key code, so it provides that key code. There's also a corresponding string associated with it. It provides that string, and then depending on the keys that are pressed, if the Alt key is pressed, the Control key is pressed, again it provides Boolean values of which one was pressed or not when the event occurred. So there is a key event demo as well. So here's the key event demo, which basically the idea is that there's the up, down, left and right arrow keys, and pressing on them moves the text. There's a character A that's on the UI. It moves it by a certain amount to the left, right, top or bottom, and then and again we use lambda expressions over here as well to do the registration. Now in this case, we can basically depend when the event occurs, because we don't know which key triggered the event, so we basically use on the event we use getCode method to fetch the key, the specific key, and depending on if that key code is down, then you do actions related to the down arrow. If it's up, then we perform the actions related to the up arrow, and so on. So that's the key event demo. So basically there's the whole list of key code constants. So there's constants that are used to codify all of the keys that are on the keyboard, and that's what this slide here shows. This next example basically shows how to control a circle with both mouse and key, so it shows both mouse events and key events being used at the same time. So let me quickly open that file. Here's the, so again it's similar to the previous examples, wherein there is a circle that's drawn, and then there's an enlarge and shrink button, so that handles the button. Using buttons you can basically control the circle, and then in addition to that there's also the it also has the mouse events, and it also has key events handled in it. So here's the buttons, enlarge and shrink buttons, and their event handling using lambda expressions. And then we also have mouse clicked, so there's a circle pane, so on it we are using the mouse clicked registration method, and then we're basically looking at the event object that we have, and the button that was clicked. If it's the primary button, then we want to enlarge. If it's the secondary button, then we want to shrink. So that's the code that you see over here in the form of a lambda expression. And then we're also doing the key pressed, and this is basically on the entire scene. Depending on which key was pressed, if it's up, then we're going to enlarge the circle. If it's down, then we're going to shrink the circle. So it's basically all of these different events are shown in this example. So let's run this example. So here's the circle, and then when I click on enlarge or shrink, it's basically enlarging or shrinking. When I click the mouse's primary button, it's enlarging. When I click the mouse's secondary button, it's shrinking. And then similarly, we can use the keyboard events, the up and down arrow as well, to enlarge or shrink it. The next thing that we'll discuss is how you can have mark certain objects as observable objects, and then have listeners on them, so that whenever any change happens in the object value, then the listener gets triggered and it performs certain actions. So basically, but then what's important is that the object has to be marked as an observable object in order to add a listener to it. There is, I'm going to show you an example of a resizable clock, wherein there is an observable object, and let's take a look at how that works. Okay, so here's our I'll show you the UI in a little bit. I'm going to quickly go over the code first. So basically we are creating a clock with a label, and this and so that's what you would see on the UI, and then we are adding listeners to see if the idea is that the clock is placed on the window, and when the window size changes, when we resize the window size, we don't want the clock to remain as it is. We want the width and height of the clock also to change correspondingly. So that's what we want to do over here. So we're basically the observable property that we're going to use is on the windows width and height. We're going to observe those, and if any change occurs on those, then we're going to automatically, so that's going to trigger an event, and then will automatically set the height and width of the clock as well. So basically the pane object, so on the pane there's width property, and that's an observable property. So basically we're going to use that, and any changes in the width property is what we're watching for. So basically on this observable width property, we're adding a listener, so we're registering a listener, and again we're using lambda expressions. So OV is the observable event that occurs, that's triggered, so that object gets generated, and then the action that we want is basically now set the width of the clock to whatever the pane's width is. Now similarly, we're going to watch the height property as well of the pane. So if the height property changes, then we're going to correspondingly set the height of the clock to whatever the pane's height is. So that's the idea over here, wherein we are now looking at the properties and which are observable properties. So let me quickly show you the resizable clock. Okay, so here's the clock, as you can see. So we have the clock and there's a label showing the time. Now I'm going to try and resize the window. As you can see, I'm increasing the width. See that the width of the circle is also changing, and then as I reduce the width of the circle or the clock is also changing. And in a similar manner I can do with the height as well, and then correspondingly you see that the clock is also changing. So that's this kind of an effect can be achieved with these observable properties, and this is important in a lot of UI programming, wherein we want to provide the ability to minimize, maximize the screen, or change the size of the screen, and correspondingly all of the UI that's inside of it should also change. So this is how it can be done. So that's all I have in event-driven programming, and we basically went over anonymous inner classes, and then lambda expressions and observable objects, and how you can use observable objects for event-driven programming. Thank you.